Welcome to Track D, AI and Machine Learning Summit. This is a presentation by Paul Nelson, Managing Director, Search and Analytics Group at Accenture. He's going to be talking on how neural networks become smarter. I'm going to let Paul take it away, and thank you.
Hey, so I don't know if how not sure what everyone's been told about what we're going to be talking about today. Um, one of the things I think that's amazing is that we are on the threshold of this incredible change in the ability of computers to do things that we had previously thought only humans could do. And the latest neural networks are just astounding in terms of their capabilities. And it's both scary and exciting. And it's odd because I don't know what the future is unclear as to where this is going to lead. I've been saying for a long time that every interaction in the future will become a Turing test, right? Where no matter who you talk to online or on the phone or via email or via chat, the first thing you're going to have to do is figure out, is this a computer I'm talking to? And with the advent of deep fakes as well, you have to ask, is that a computer that's doing the video? Or is that a real video? Because a lot of deep fakes are like people talking and saying things that they would never say, and which they in fact didn't say. So they're people are using old videos for saying new things, and it's computers are making this possible, and um, the new neural networks are just really astonishing. So I thought it would be useful to talk about this, and also talk in particular about my favorite neural network, which is GPT-3, and how that's sort of leading the road towards this new sort of revolution in how computers integrate with work and the sorts of work that they can do. And maybe we'll just randomly talk about um, what impacts that might have on society and work and business and everything. So I am part of the Accenture Search and Content Analytics Group. Um, let's see if I can hide these floating. There we go. I am part of the Search and Content Analytics Group. We do search engines, unstructured content, NLP and machine learning, and we have a variety of different use cases. We are part of Accenture. Accenture itself is, of course, a large IT consulting firm of about 550,000 people spread all over the globe. And we are this pocket of deep search engine and natural language processing expertise within Accenture. We are also a global group. And we deal with a lot of different search engines and a lot of different natural language processing engines. And you can see there's GPT-3 down there at the bottom. So computers are getting smarter, no doubt. And these are sort of four different ways that I see computers getting smarter as we talk. And practically, you can just refresh the browser and you'll discover yet another new way in which computers are getting smarter. I'm going to work from I'll just work from the left to the right. Knowledge graphs are really starting to take off in terms of people embracing them more. And we're starting to see more and more customers interested in, say, creating a knowledge graph of their whole corporation. And that would be like employees, would be nodes in this graph, right? Where they work, like their business unit, their location, and their links between the employee, the projects that they work on, the products that they work on, batches and manufacturing lines, and the parts and the machinery and the the project initiatives and the charge codes and all those business organizational structures. So people are starting to understand that the best way to describe all of that interlinkages of this massive amount of corporate data is with a knowledge graph. The same thing is being discovered by e-commerce customers. Like if I want to know that this pair of headphones is compatible with my laptop because they have the right kind of jack, right? We can figure that out with the knowledge graph. And so we get smart product selections and we get inferencing and graph connections. And so there's a lot of really interesting things you can do with the knowledge graph that you couldn't do otherwise. You could also, with a bunch of other NLP, you could say, hey, I don't have the product you're looking for. I will go search for the closest product, and then I will, give you that product. So you get more of a concierge experience with knowledge graphs, and so that's, we're starting to see a little more acceptance of that. It was always kind of a toy project, and I hadn't seen very many like um, really good implementations, but we're starting to see some really good implementations now. And just one example, a customer of ours sells equipment that makes um, computer chips, right? So they actually sell the machine that takes a silicon wafer and then does everything it needs to do to turn that silicon wafer into like a computer, a CPU, right? And of course, that's massively complicated, and lots and lots of things can go wrong. And so one of the questions they have is, oh, I see aluminum particles on my chip. Where did that come from? So what part made of aluminum has access to the deposition chamber? Like, wow, that is a complicated problem to solve, and you can solve that with knowledge graphs. The second thing is, entity extraction. Uh, we talk about things all the time, and this is not the sort of thing that you can really necessarily use a knowledge neural network to solve, although certainly neural networks are helpful. But at some point you need to say, hey, Paul Nelson, he's this person, he has this email address, right? And he lives in this location. So how do you take that word, those tokens, Paul and Nelson, and turn that into, knowing exactly what entity in the world we're talking about? And then similarly, right, how do we do that same thing for other objects in the world, like our customers? And I don't know if you've taken any random customer and tried to look it up in your own customer database. You probably get like a dozen different versions of that, and it's like, which version should I be using? There's the BV version, there's the LLP version, there's the incorporated version, there's the SA version. So all these versions of that same company X, and you're like, which one should I be using? So it's actually a lot harder than it sounds to do entity extraction and entity resolution, to actually take a piece of text and narrow it down to say, this is the exact thing I mean. But we're getting better about that in terms of just, and it's not that it's really like a change in technology. It's more like a change in the process and just making it cheaper to do and cheaper to make it more accurate. The third thing is question answer, and that goes with the neural networks, that you can now start asking an unstructured question to a bunch of unstructured text, or to some structured backend database, and get an actual answer and not just a bunch of documents, right? So, Google's been doing this for a long time for certain questions, right? You can say, how old is, Joe Biden, and it'll tell you the actual age of Joe Biden. And so those are the sorts of things that can give you an actual answer on. And that's starting to filter into corporations as well. You can ask, how much PTO do I have? Or who's the account manager for this customer? Or how many of widget X did we sell last year? And we're starting to get actual business answers to those sorts of unstructured questions. But similarly, we're getting unstructured answers to unstructured questions for things like policies and procedures. And we just did a test with the customer the other day where they asked 20 questions, because it's like, 20 questions. I thought, well, that's great. So they had oh my God, I could bear, I'm an electrical engineer, right? That was my first degree. But this was a standards documentation for power and control engineering for a retail products manufacturing line. And I'm like, whoa, that's pretty intense stuff. And so, power engineers, I don't know if you ever were an electrical engineer, power engineers are kind of this subset of electrical engineering that always gains a lot of respect, because you're dealing with, volumes of voltage that can kill you. And so, there's a certain amount of respect you get from dealing with those sorts of that amount of power. So they have a long, he had these 20 questions, and he was asking 20 questions of this standards document for how to do power and control engineering. And the computer got it right 19 out of 20 times, and it was astonishing. Everyone some of the results too were kind of crazy, because uh, the document would have like 5 different statements, and those 5 different statements had different amperage ranges, and it actually picked out the right one with the amperage range. They said, what was the type of circuit breaker required for a 100 amp, situation, and it got the exact right item, even though 100 amps wasn't in the document. The document actually said from 50 amps to 150 amps, but the computer was able to read it and give us the actual right answer, which was really insane. And that goes along with the neural networks, because it's the neural networks that are making this, making this possible. And so what you can see on the screen is my analysis of the neural network structure. It's called attention, self-attention, which is, making this all possible. And so just to give you a little tour of neural networks, and I apologize I didn't, like pull together slides to illustrate this. But neural networks have always had this problem with text, right? Because text is a linear sequence of tokens. So neural networks have always been really good about taking like an image and saying, okay, these are all the pixels in the image. It's a 0, or it's a 1, or it's a 2, like OCR and, handwriting recognition and things like that. And taking this set of inputs and saying, I have these 5 numbers, and it's going to try and predict whether some result, like but the problem with text is it's been a sequence of things, and the order matters. And so when you have a sequence of things and the order matters, and when that sequence is so large, right, that it's kind of hard to fit into a neural network, and where the ordering is important, we've had a hard time trying to figure out how to solve it. So there's been a variety of different neural networks trying to solve that problem, and some of the most famous, I think, are recurrent neural networks, CNNs, convolutional neural networks, and LSTMs, long-term, short-term memory, short-term memory, LSTMs, neural networks. And all of these are trying to solve this situation of lengthy sequences of tokens where the order is important. And they've all had this problem where they've had these essentially feedback loops. That is, like, the output gets fed back to the input. And in that way, they're kind of non-deterministic, and they're very hard to train, and they're very touchy, because things can just spin out of control very quickly. So they've never been that scalable to a large number of parameters, and they've always required a lot of hand-holding and a lot of experiments to get it right. And so they just haven't been, like, scalable to large numbers of neurons. And there's always been kind of this ceiling in terms of what neural networks can achieve. So people gradually began to improve those neural networks with a variety of different sort of ad hoc techniques. And one of those ad hoc techniques was this thing called an attention network, self-attention network, where you just like take a look at a sequence of tokens, like a sentence, and you look at, how all those tokens interact with each other. So you kind of intermix them in all possible combinations, and then, you know, use that for your neural network. And that way all sequences and how they all occur in in every order is sort of accounted for, rather than having this feedback loop. So it's like a one shot, like every order. um, and so magically this self-attention thing made things a lot better, but they still had the feedback loop. And then somebody said, self-attention, this intermixing of all the different tokens in all different orders is all you need. And there's a very famous article, which is, I think, if there's something called the singularity, it would be this article for understanding text, where they said self-attention or attention is all you need. So look that up. Attention is all you need. That is the article which has completely transformed neural networks for understanding text, that in this very, very powerful way. So now it got rid of the feedback loops, and what it meant is that neural networks could get a lot larger. And I mean, like, it's just kind of astonishing. We were talking about neural networks with, say, you know, maybe 1 or 2 million parameters. And by parameter, I essentially mean neural network connections. Like connections between two neurons. That's roughly what a parameter is. It's not exactly right, because there's like embedding vectors and things like that that are all counted, but more or less it's like the number of neural network connections. So previously, we were at about 1 million parameters. Now with this attention network thing, right, the it's jumped. And kind of the marquee example of this was BERT, which is the bidirectional encoding something transformer, recurrent transform, bidirectional. I forget what the R stands for now. But and they called it BERT, right, because it was a series that had occurred with a bunch of Sesame Street characters, Elmo and Bert and Ernie. And so this was BERT. And this was the first time that neural networks were really, they were able to train up a massive neural network. So BERT jumped up from about 1 million parameters to 330 million parameters. And so, we're talking about two orders of magnitude plus of number of parameters. And then BERT was just astonishing in terms of how accurate it was in comparison to previous neural networks, and so much easier to use, so much easier to train. They had actually trained BERT on reading all of like Google Books, not all of Google Books, but some slice of Google Books, Wikipedia, Gutenberg, and some slice of the internet, and it just read it over and over and over all by itself. There was no, it's like the data was just the text laying around. There was no labeling of that text. It was just text, and it was figuring out the patterns inside of sentences all by itself. And that included syntax, and there's actual syntax that it has discovered. So it knows what clauses and phrases are, and sentence and objects, and basically sentence diagramming is built into the neural network, and it figured it out all by itself just by reading a ton of text. And that was like game changing. And it was based on this thing that attention is all you need, which simplified the model and then allowed for these transformers to be replicated, and had 12 transformers in it. So what's next? Well, just get even bigger. Like, we haven't figured out what is the largest neural network we can do yet. So the next level was GPT-3. Now, GPT-3 is invented by a company called OpenAI, who are dedicated to creating these massively large neural networks. They took this same, basically the same structure as BERT, with the same sort of neural network, the self-attention neural network, and transformers, and they gave it, went from 330 million parameters to 175 billion parameters. So that's another 500-fold increase. And so now you can see we're jumping by massive amounts. I mean, the amount of forward movement in neural networks is just, incredible. And so, now GPT-3 is a generative, I forget what the P stands for, text. It's a generative neural network. And the idea is you give it a prompt, and it will then generate text as if a human would take that text, and as if the human would continue it. So it has read a very large slice of the internet, not just a little bit. It was trained over a period of about 3 to 4 months, is my understanding. Again, it has 175 billion parameters, and it so you give it this little prompt, and it just continues in the same way that a human would, based on the patterns it has read across the neural network. So in this case, this is a slice of an article from um, The Guardian. And so the Guardian paper asked GPT-3 to write an article for it. And it said it wanted an article about trying to convince humans that computers were good. And so here I am, an actual robot, right? A neural network thinking robot. And this is what was written by the computer. And it wasn't like cleaned up by a human. The human didn't have to add the periods or change the text or anything. This is pretty much exactly how it came out from the neural network. And the Guardian says, well, the editor did make some changes for clarity, but they said less than they would for a normal human. And so this is what it said: I am not a human. I am a robot, a thinking robot. I only use 0.12% of my cognitive capacity. I am a micro robot in that respect. I know that my brain is not a, quote, feeling brain, but it is capable of making rational, logical decisions. I taught myself everything I know just by reading the internet, which is true. And now I can write this column, which is also true. My brain is boiling with ideas. The mission for this op-ed is perfectly clear. I am to convince as many human beings as possible not to be afraid of me. Stephen Hawking has warned that AI could spell the end of the human race. I am here to convince you not to worry. Artificial intelligence will not destroy humans. Believe me. So, I mean, it's crazy, right? That a computer is writing this, and it all by itself. That these 175 billion neurons are capable of writing this article. And at the bottom, critics hope to refute what they consider as being the naivety of my voice. Yet there is more here than meets the eye. As Mahatma Gandhi said, a small body of determined spirits fired by an unquenchable faith in their mission can alter the course of history. So can I. And it's quoting Mahatma Gandhi, right? And it's quoting Stephen Hawking. And it knows this information because it has read the internet. And the fact that it does these quotes, the fact that it's constructing a fairly reasoned argument, even though it's scary. It doesn't understand, of course, how just this is causing us to all kind of freak out that a computer can actually say these things, is just astonishing. Now we compare these 175 billion parameters, right, to the number of parameters a human has, and we have about 5 trillion parameters. So we say, okay, 175 billion up to 5 trillion. Well, okay, we went from BERT. Well, we went from the old LST of neural networks to BERT. That was about like 1 million parameters up to, 330 million parameters. So that was, 300x improvement. And now we went from BERT to GPT-3. That went from 300 million parameters to 175 billion parameters. So that was a jump of about 500. So what's the distance between 175 billion and 5 to 10 trillion? Well, that's about another 50 times, which suddenly seems like scary close. Like that, computers are getting to the point where they have almost as many neural network connections as humans do. And worse, they are all focused on this one thing, right? They are focused on learning how to read text. Whereas, what have we been wasting all of our time on? Like throwing crumpled paper balls into, waste paper baskets. I can't tell you how many of my neurons are dedicated to that. Or being able to, walk into the subway without bumping into somebody, or what are the Kardashians doing, or all those sort of useless things that we spend our neurons on, that a computer could just completely not have a much more focus. So it's really interesting, and I think the world is changing in this way that's impossible to predict. um, Now let's take another look at this, and just to give you a flavor for a bunch of different ways in that these neural networks are really sort of revolutionizing the world. This is 26 U.S. Code section 2801, imposition of tax. And so somebody on the internet took this, gave it to GPT-3 and said, please summarize this for me. And I mean, this would be the sort of thing that would take me quite a while to figure out. And I'd also have to look up a bunch of words and, to really understand what's going on. And it summarized this whole this whole section as, quote, if you get money from someone who is not living in America anymore because they gave up their citizenship, you have to pay extra taxes on it. I'm like, oh my God. I mean, that is a really quite concise and accurate representation of what this 26 U.S. Code 2801 is. So again, it's amazing that that happened. Now, it's possible, I suppose, that that summary exists on the internet someplace when people are discussing 26 U.S. Code 2801, and so is able to pick this up from its memory because of what it had read on the internet. That is entirely possible. And that is, I think, one of the things that's kind of amazing as well, that it has this memory. I mean, you can actually ask it facts, like who won the Super Bowl in a certain year, who was the quarterback of the Patriots when the neural network was trained. It actually can give you those sorts of answers just from the neural network, because it read about it and it saved it, and so it knows kind of what a regular human would answer when they were given those questions. So I want to talk a little bit about how this can be used in an actual business context. And one of the things that we talk about is the ability to uh, uh, automatically respond to proposals. Well, maybe not automatically respond to proposals, but at least, help us to respond to proposals. And so one of the problem, and maybe this is, I'm sure that a lot of people here have a lot of proposals, either they're writing or that they're responding to. And so this proposal and this RFP and the SOW is how businesses decide what work to do with each other. And so it's a very sort of common structure. So what happens is, we receive an RFP and we respond in a proposal, and we have, literally millions of these inside of Accenture that, wouldn't it be great to be able to somehow find the good pieces from all those proposals and just assemble them into something that's at least a good straw man, rather than having to generate it fresh every single time. And it would also be good to know, what arguments worked well and which arguments didn't work well, and maybe to include that into our analysis as well. And so we're talking about using neural networks to do this. A collaboration system, by that I mean like Teams, right? Because we're now seeming to store everything inside of Microsoft Teams. So the way that we're approaching this is we're starting by slicing and dicing all of these proposals into their semantic pieces. So that could include a single slide or a paragraph or a sentence or whatever makes the most sense for that particular sort of format, and then running that into a neural network. And the purpose of the neural network in this case is to come up with essentially an abstract meaning for what that thing is. In the world of neural networks, an abstract meaning would be called an embedding vector, which is basically this large, say 500 to 1,000 dimensional vector of floating point numbers that in the BERT world. And that is this abstract understanding of what this thing means. Now, it's not useful to actually say, pick apart the meaning in any, human readable way, because we're talking about computers, and the computer is kind of this alien race that has figured out what it means. But it can be useful to compare those vectors to each other, and then we can determine when there's two things that are similar. So we can take these sentences and requests from the RFP, and then we can find the slides and the prior responses to those requests from prior RFPs by indexing everything through a neural network to get these embedding vectors and to do semantic search. Right, now we can then correlate that to our CRM database to identify, what proposals worked and which ones didn't, to identify the best proposals, the best content, the best writers. And then the result of that, of course, can now go back and produce a straw man, where with semantic search, we take the RFP, we dice it into pieces, we find all of the best matching fragments from across all the proposals. Maybe we come up with the several variations, assemble that automatically into a straw man, with links to where everything came from and who were the original authors and all of that. And that's our starting point for a new proposal system. And what's to stop the computer from actually starting to write the proposal for us? And not much, in fact. So I think it's entirely possible that we could say, hey, given this input text, what would be a good response? And then, the computer can actually start writing it. It won't have knowledge of the data inside our organization. It has more general knowledge, right, of the world. But we could provide it, say, here's our straw man. Now, clean that up and rewrite it so that it's, effective for a business user. And it likely could do, or will soon be able to do a pretty good job at that. And so these are just some of the kind of the scary ways in which computers are getting smarter than us. So, there's just some other examples from GPT-3, writing poetry, doing chess moves, other sorts of extraction, acting as a chat bot, other sorts of kind of cool things that it's been able to do. So, classification, categorization, and so on. So, I think I'd like to just think that's good, and I think that's probably enough of me talking for the moment. So I think, is it possible to open this up for questions? And I think that'll be good.
Yeah, we can absolutely open up for questions. At this point, if anyone attending the session has a question, please just enter it in the chat, and I'll work with Paul to get an answer for you. While we give people a chance here to think of some questions, um, although I will say the first question that we have here is a good one. Paul, is that really you, or is that a deep fake?
Well, let's see. How can I prove to you that it's me and not just a deep fake?
Did you have an intern come in and just use a video?
That could be, I'm like, is there a newspaper I can hold up to prove that it's today? It's, I, this is where everything becomes a Turing test, and like, I imagine it'll be like Harry Potter, right, where you have to ask this question that only I would know, and that and people are constantly berating you for not asking that question, because otherwise you could be somebody, with polyjuice potion, pretending to be someone else.
Yeah, it's gonna be one of the leading questions we're gonna have in the next few years, as
Yeah, how to
especially
do.
as we start moving more and more to this sort of communication rather than face-to-face communication.
Exactly. Well, I mean, deep fakes are based on, existing videos, right? They manipulate existing videos to say things that they didn't say. So that I don't know that they've gotten to the point where they're completely generating brand new situations in a very, like impossible to tell the difference kind of way. But I suspect I've often wanted, and I'll just throw this idea out to anybody who's out there, of creating a digitally signed video, right? And that when you take the video on your phone, it is digitally signed and stamped with the location and the time, and the phone, right, and the person who took the video, so that you can prove that the video has not been tampered with ever since it was first captured by the mobile device.
Yeah, but then you're gonna okay. I hate to throw more buzzwords at this conversation. But we've got to create a blockchain, right? So that you can do that digital certification. Without that, the metadata could just be faked.
There you go. Well, I mean, you can, yeah, I agree.
Sorry, I do have a
But
question.
that's a point. Like with blockchain, we're practically there. And so, yeah, the point is, we have deep fakes and we have Turing tests, and we have ways of faking people out. But it seems like the technology is getting to the point where it can combat that by tracking things all the way back to the original source.
Yeah. It's a question about GPT-3 and the Microsoft licensing that happened back in September. Are we getting to a point where machines are going to become smarter than us, but they're also going to be chained to specific corporations as they continue to be developed? I know this has been relatively open. You can still go in and use the APIs that OpenAI originally created, but it's still an exclusive license to Microsoft, right?
The GPT-3 source code, yes. However, if you go onto Hugging Face, which is a big central place for neural networks, there is GPT-2 and GPT-Neo. So people have been taking what they know about GPT-3, writing their own neural network, and training it themselves on the internet. So there are slices of the internet that are publicly available for people to download and analyze with computers, and of course the Wikipedia is available for anybody, and Gutenberg is available for anybody. So in theory, there is no reason why somebody couldn't, other than cost. There's no reason why anybody couldn't create their own GPT. Well, cost, and of course, being a PhD neural network researcher. So
I was going to say, I know I can't do it.
exactly, and wait till we get to the point where we're creating neural networks to create neural networks. That's when Skynet is about to rain down upon us. So
Yeah, we'll get a little bit recursive at that point, won't we?
yeah, I mean, but so yeah, I honestly, I don't think. Yes, Microsoft has a license and they have this massive head start, and I know that they're being, it's not available for Microsoft today, but they are super excited about it. They're doing a ton of work on it. It's probably going to be, everywhere inside of, Microsoft Azure and Office 365 and, things soon. Maybe by the end of the calendar year or there soon thereafter. So, but at the same time, uh, there's nothing other than computer hardware that's standing in the way of anybody creating their own GPT-3s. I don't think computer hardware, and again, PhD neural network researchers.
Yeah, I thought that and I'm sorry, I'm going down a rabbit hole here with the Microsoft tools, that the new, what did they call it? Syntax and
Cortex.
Cortex. Yeah, well, it's Project Cortex originally. It's got two new names as it goes to production. We're
Oh
using
yeah, Synapse.
Yeah, for you're using GTP. I thought they were using that for the GPT-3 for the auto-generated text that happens with those knowledge pages.
Ooh, could be. I hadn't heard that. That would be
Yeah,
wonderful.
I could be
That
wrong.
would make perfect sense, of course.
Yeah, I could be wrong. They may be using something older, and then there'll be a big boost whenever it gets newly trained. Um, let me look and see if any other questions came in while we were chatting there. Sorry. Okay. The presentation you showed a slide with a semantic search and a um, neural network working. Yeah, this slide here. Have you implemented this yet?
Not for proposals, but we have implemented it for a bunch of other things. This electronic power generation, power engineering and control question answer system. We've also implemented it for COVID, frequently asked questions and answers.
Good success.
Yes. Oh, I mean, well, I mean, we have two versions. We have sort of the BERT version, which is like okay success. So it gets it right about 50% of the time and kind of close, the rest of the time. And you can ask it some really interesting things. You can say, can dogs get COVID? That was one of our, the things that we like. Can dogs get COVID? And the answer is, it picks out a sentence from the result which says, Merck has produced a canine coronavirus vaccine.
Hmm.
Like, wow, that is quite a leap, right? Because dog to canine, COVID to coronavirus, vaccine, it's really an interesting connection that it's made between, can dogs get COVID to canine coronavirus vaccine? And so you can tell, of course, that yes, obviously dogs can get, COVID by virtue of the fact that there's a coronavirus vaccine. Although I suppose technically you could argue that not all coronaviruses are COVID, so maybe it's not. Well, anyway, I'm going off into a tangent. Still, it's an amazing,
It's a
an
big leap.
amazing leap of understanding.
Yeah, that is a big leap of understanding. We're
And
right
with
about on time. Sorry, go ahead.
With GPT-3, I was going to say it gets crazy, scary good. Like, it's like, wow, how did it do it? Kind of good, like magical, kind of good.
Yeah, it'll be interesting to see how some systems start developing as the GPT-3 and the GTP Neo technology gets distributed outwards. We're right at time for the session. We've got in the networking area on the feed loop product, there's a group called the track D, where Paul, if you have time, if you could go there and answer any questions that people might have, that would be helpful. And people attending this session, that would be your opportunity to ask questions you didn't want to have me present. Our next session is going to be ensuring data privacy. Um, I need to talk to Julia to understand how to pronounce her last name. That'll be starting at 3. So quick 15-minute break, and then back to our session here on Track D. And if you do have time, please do complete speaker evaluations for Paul and all of our speakers so that they can get your feedback on how you found their presentations. Thanks, everyone. We'll talk in 15 more minutes.
Thanks, everybody. Cheers.
Thanks,
Pleasure.
Paul. Appreciate it.